In the last video, I covered Java's built-in locking mechanism, which is implicitly used whenever you declare a synchronized method or statement. Next, I wanted to talk about the wait and notify methods that are defined on the object class and used when threads acquire the monitor lock. To demonstrate this, I'll set up a producer consumer application. This kind of application has a class that produces data, so the producer. It also has a class that reads the data or consumes it in some way. This is the consumer. I've created a new project called Consumer Producer for this in the dev LPA package. Before I code anything in my main method, I'll create a couple of other classes. The first, I'll call message repository, and I'll put this in the main.java source file. This class is going to hold a single message. I'll place this class just above the main class. Both the producer and consumer will interact with the message, so it's a shared resource. I'll include a Boolean field called hasMessage, which will indicate to both threads whether there is work for them to do. When hasMessage is false, the producer can populate the shared message. When hasMessage is true, the consumer can read it. Next, I need methods that read the message as well as write to it or populate it. Because the message is a shared resource, I'll synchronize the read method. When the consumer class calls this method, it will wait until there's a message to read. I'll set this up with a while loop on the message flag. If there's no message, it will stay in this while loop. I'll just make this an empty block. Once the message is successfully retrieved, this code will set hasMessage to false. Finally, the method returns the message to the consumer who's waiting for it. The write method will also be synchronized, and it takes a string as an argument. If there's already a message in the message repository, it will hang out and wait, presumably until the consumer has a chance to read the message and set this flag to false. Once there's no more message, meaning it was consumed, the hasMessage flag will be set back to true because this code sets a new message. I'll set that message here as the final step. Okay, so that's the shared resource that both the consumer and producer are interested in. Now, I'll write the producer class, which I'm going to call MessageWriter. This class will implement Runnable. I'm getting an error on the class because I need to declare the run method, so I'll do that now. Before I implement the run method, I'll add a couple of fields. The first field will be a message repository item, and I'll call that outgoing message. For the source of the messages, I'll use a nursery rhyme, setting it up as a text block. And you probably know this nursery rhyme: Humpty Dumpty sat on a wall, Humpty Dumpty had a great fall. And I'll just finish this off. All the king's horses and so on. Couldn't put Humpty together again. I'll create a constructor next, and that'll take a message repository as its argument. I'll get IntelliJ to generate it for me. Okay, so those are the fields and the constructor. Next, I'll implement the run method. I'll use random to randomize the time that the thread sleeps. I can get the lines of text by splitting the text block by the new line character. I'll loop through the lines using a for loop. I'll write each line of text as a new message to the outgoing message repository instance. I'll call the sleep method next, so I need a try block here. I'll wait between half a second and 2 seconds, a randomly chosen interval. This means this code writes a message and waits a bit before writing the next. This gives the consumer a bit of time to read it. I'll catch the interrupted exception thrown by the sleep method. If this does get thrown, I'll wrap it in a runtime exception and rethrow it. Okay, so that does it for the producer class. Next, I'll work on the consumer class. I'll call it MessageReader, and again, I'll make this class implement runnable. This class will also be in the main.java source file, and I'll place it just above the main class. When I add the implements runnable clause, it gives me the same error message as before, so I'll get IntelliJ to generate the override for the run method. I'll do the same thing I did with the MessageWriter class, so I'll add an incoming message field before I implement the run method. The field is going to be a message repository type. Once again, I'll get IntelliJ to generate my constructor for this class. Now the only thing left to do for this class is to implement the run method. I'll again use random to randomize the sleep time. I'll set the latest message to an empty string. Here, I'll set up a do-while loop. I'll include a try-catch block because I know I'm going to need it. Inside the try block, I'll put the thread to sleep first. This gives the writer a bit of time to get its message out there before this code attempts to read it. I'll include the usual interrupted exception clause. After this, I'll read the incoming message and then assign it to latest message. I'll print that out. The do-while loop will keep looping until latest message equals finished. This is the message returned when the producer is done writing out the nursery rhyme messages. Now that I've got both classes, the consumer and the producer, it's time to start them up working asynchronously. Getting back to the main class's main method, I'll first create an instance of my shared object. This is an instance of the message repository class. Next, I want two threads, one for the message reader and one for the message writer. I'll declare a thread variable called reader. I'll assign it a thread instance. I'll pass a message reader instance to the constructor of this thread. The message reader is constructed here too, and it's passed the message repository instance. I'll do something very similar for message writer. Both threads are working with the same instance of the message repository class. I'll then call start on both variables. Let's give this a try now, so I'll run it. Usually, I'll get one or two messages printed out and then the code will just hang. You might get no messages, or you might actually have the code complete with no issues at all. This is the maddening effect of a concurrent application that has a problem. Sometimes it's really hard to reproduce multi-threading problems because it's based on thread management by an operating system. Obviously, I shouldn't have to wait much longer than 2 seconds for something to happen, so I know I've got a problem. I'll quit the application when it does hang, and I'll try it a couple more times. Each time the output is a little bit different, but it usually locks up. Maybe you already can guess why it's hanging here. There are several situations that can occur in a multi-threaded application that are pretty undesirable. These situations are called deadlock, live lock, and starvation, and later in this section of the course, I'll talk about them in more detail and compare them to each other. In this particular case, I've created an application that can produce a deadlock. A deadlock usually occurs when you have two or more threads accessing multiple shared resources, and I'll cover that scenario in a later video. But it can also occur in the scenario we've just seen in the case of a single resource with multiple synchronized methods. Thread A is our consumer, the message reader. It can usually get in to run the read method because the hasMessage flag is usually true. So when that flag is true, it won't go into the while loop. But if for some reason the flag is false, it will execute its while loop, and that's where the problem lies. It's waiting on that hasMessage flag to change value to exit the loop. But because of the way this code is currently written, that flag is never going to change its value. Thread A has acquired a lock on the shared resource, in this case the message repository, and thread B can't get that lock, so it's blocked. Because thread B is blocked, it can't change the flag that would set the condition to let thread A exit its while loop and release the lock. The threads are stuck, one spinning indefinitely, the other blocked from doing anything. This is a classic deadlock situation, and the resolution isn't always pretty. In this case, I have to shut down the application or kill it manually. This situation could be equally true in reverse. This means the producer could be in its while loop, waiting on the consumer to flip the flag, but the consumer can't get the lock to do it. So what can we do? I'll pause the video here and answer that question in the next video.